200 ohms. Now, band 4 now, for example, band 4 is gold. Gold, it means that plus or minus 10%. It means that 200 ohms plus or minus 10% of 200 ohms.
So it could be between 100 and 90.
Yeah. So now 5% of 200 ohms is how much? 10 ohms. Is it right? You calculate 5% of 200 ohms. You take 5% multiplied by 200 ohms, you have 10 ohms. This is the tolerance. 10 ohms. Do you understand? So I repeat, 10% of 200 ohms. So you take the 10%, 5% of 200 ohms. So 5% of 200 ohms, this is 10 ohms. So the fluctuation is more or less 10 ohms. It means that the range of the value is, instead of 200 ohms, it could be smaller by 10 ohms or greater by 10 ohms. So the range here will be from 190 ohms to 210 ohms. Is it right? This middle point is 200 ohms. This is a nominal value. But the variation, the fluctuation here is plus 10 ohms or minus 10 ohms. Okay, so this is the band 4 tolerance. So for one resistor, the tolerance 5% and tolerance 10%. Which one is better? 5% is better. Why? Yes, the range of variation is smaller. It means that the value is more exact. Okay, is is with more precision. Okay, so that 5% is better than 10%, and 10% is better than 20% of tolerance. So that it will determine the price of the resistor. If you buy the resistor with 5%, it is more expensive than the resistor of 10%. Okay? Do you understand? Okay. All right. So this is for the 4-band code. Now the second type of code is 5-band code. Five-band code. So we have a 5-band. Band 1, 2, 3, 4, 5. The method of reading the color code is very similar to the case of 4-band. However, now for 5-band code, we have band 1 will be the first digit, band 2 the second digit, band 3 now will be the third digit. Band 3 is the third digit, and band 4 now will be the multiplier. Number of zeros we add, okay? And band 5 now will be the tolerance. So the method of reading the values are very similar. But now we have 3 digits, band 1, band 2, band 3. And next the multiplier. Now, for example, in this picture, band 1, band 1, band 2, band 3, band 4. Band 1 is brown. Band 2 is black. Band 3 is black. And band 4 is brown. Now, what is the value of this resistance? Sorry?
1,000.
Yeah. Brown, black, black, brown. Brown is brown here is number 1. Black is number 0. Black is number 0, and brown here is 1. So the first digit is 1, second digit is 0, third digit is 1, it is 0, and then the last band, the band 4 is 1. That means we add 1 0. We add 1 more 0 after the second and third digits. So finally, this is 1,000 ohms. Or it is 1,000 ohms, it is 1 kilo ohms. 1 kilo ohms. Okay? Band 5. Band 5 now is a tolerance. Band 5 is tolerance. So for the case of the 5-band code, so the tolerance here is a little bit more complicated. So gold is still plus or minus 5%, silver plus or minus 10%, but with the other color, so the tolerance will be very small. Tolerance small. It means that the range of the value is very, very narrow range for the 5-band code. So generally for these 5-band code resistor, so the tolerance is very small, is very narrow. And then the 5-band resistor is generally it is more expensive than the 4-band. Okay, any question? Okay, so now we will take the break. The break will be in 20 minutes. Okay, 20 minutes. So I repeat, in the first part, we told about the color code, 4-band code or 5-band code of resistor. So you have you are able to read the values of resistance. Now we come to the next section. Next section, Ohm's law. So the first basic law in electrical circuit, Ohm's law. Ohm's law is the first and very, very basic law of electrical circuit. So now we consider one resistor R here, one resistor R, and we connect a source. A source, the voltage of the source is E. We apply this source on this resistor R. So when we connect the source E to this resistor R, so the voltage on this resistor will be the same as the source voltage. The voltage V here on this resistor is the same as the source voltage. V is the same as E. So the voltage on this resistor between the two terminals of resistor here. So I repeat, when we apply a source voltage E on this resistor, then the voltage on this resistor, the voltage V is the same as the source voltage E. And then now there will be a current. There will be a current from the source. This current flows here. There will be the current from the source, the current I. There will be the current I from the source flowing across the resistor. So now on this resistor, there will be the voltage V, and there is a current I across this resistor. So tomorrow, when we do the lab 0, when we practice in the lab 0, so I will explain you how to use the multimeter to measure the resistance, to measure the voltage, to measure the current on this resistor. Okay? So tomorrow we will measure the values of our resistance. We will measure the voltage V, and we will measure the current I on one resistor. So by using the lab materials, tomorrow I will explain to do that. Now I repeat, on this resistor R, now there is the voltage V and the current I. Ohm's law define the relation between the voltage V here, the current I, and the resistance R on this resistor. The relation between voltage, current, resistance. This is Ohm's law. Ohm's law. So I add the one page here. Now, basically, Ohm's law. Ohm's law says that V is R multiplied by I. So this is the basic relation. V is R times I. So I will redraw the circuit here. We have one resistor R here. the voltage is V, and the current here and the current here is I. So Ohm's law defines R and I. V is R times I. Current. Yeah. Yeah. I is current. V stands for the voltage. And R stands for the resistance. So R here is resistance. The unit of R here is in ohms. I stands for the current. The basic unit of current is ampere. Ampere. We use the capital letter A representing ampere. A. Current has the unit ampere. A. And V stands for the voltage. The unit of voltage is volts. Volts. So voltage in volts, resistance in ohms, current in ampere. Now, example. If we have the resistance R is 100 ohms, the current I here is 2 ampere. So by Ohm's law, what is the voltage V? (200 volts unit? 200 volts. Okay, so please read say the unit. Okay, V is R times I. R here is 200 ohms. I here is sorry. R here is 100 ohms. I here is 2 ampere. So you multiply, you obtain 200 volts. Okay. Now, for the unit of current, I. So the basic unit of current I is ampere. A here stands for ampere. Ampere is the basic unit for calculation. However, beside this unit, the current has the other unit. The other unit is milliampere. We write milliampere. The lowercase letter m, ampere. So lowercase. M. Lowercase letter m, it stands for milliampere. Milli, it means that this is 1,000 times smaller. 1,000 times smaller. Okay, so 1 ampere is 1,000 milliampere. So milliampere is smaller than ampere. Milliampere is 1,000 times smaller than ampere. So then we write 1 ampere is 1,000 milliampere. Or we can write this is a 10 power 3 of milliampere, 1 ampere. Okay? So 1 ampere is 1,000 milliampere or 10 power 3 of milliampere. Inversely, 1 milliampere is 1,000 times smaller. That means the inverse of 1,000 of ampere. One milliampere is 1 over 1,000 of ampere. It means that this is 1,000 times smaller than ampere. Okay, so you write 1 over 1,000 ampere. Now, instead of writing 1 over 1,000, we write 10 power negative 3 of ampere. 10 power negative 3, it means that 1 over 1,000, 1,000 times smaller. Okay, so I repeat, here we have the unit milli, lowercase letter m. So please pay attention that when you write lowercase letter m, that means milli. But if you write capital letter M, it means mega. They are quite different. Okay, so please do not be confused in writing unit. If you write capital letter M, this is mega, 1 million times larger. But if you write lowercase letter m, this is milli. This is 1,000 times smaller. Okay, so please distinguish them. Milliampere. So next, beside milliampere, there is also another unit of current, which is called microampere. Microampere. Microampere, the symbol is micro is here. This is a micro. Microampere. So this is one Greek letter. However, this letter micro is quite difficult to type. So instead of writing micro like this, you write UA. It also means this is micro. So by typing on the calculator, so we use the letter U instead of the micro. So you should understand the U here. It also means that this is microampere. Micro. So microampere is 1 million times smaller than ampere. 1 million times. So that means 1 ampere is 1 million times 1 million microampere, or 1 microampere is 1/1 million of ampere. So 1 ampere is 1 million of microampere. 1 million is 10 power 6. 10 power 6 is 1 million. Sorry, 10 power 6 microampere. 1 ampere is the 10 power 6 microampere. That means 1 million microampere. Inversely, 1 microampere is 1/1 million of ampere. So instead of writing 1/1 million, so we write 10 power negative 6 of ampere. 10 power negative 6. It means that that's 1/1 million. Do you understand that? Okay. Okay. So now example. Now we have the current 0.1 milliampere. So convert into ampere and convert into microampere. If we have the current 0.1 milliampere. Yeah. So you see that milliamp is 1,000 times smaller than amp. 1,000 times smaller. So if you convert from 0.1 milliamp, so you should receive 0.0001 of ampere. Yeah.
100 micron.
But if you convert from milliampere to microampere, so 1 milliampere is 1,000 microampere. Okay, so 0.1 milliamp is 1,000 microamp. So you convert 0.1 milliamp, you should obtain 100 microamp. Okay, so this is the unit of current. Now, similarly, we have the unit of voltage. So the basic unit of voltage is volt, V here. The capital letter V, it stands for volt. However, beside volts, we have millivolts. 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 Lowercase letter m, volt. This is milli. Lowercase m. So 1 volt is how many millivolts? 1 volt is 1,000 millivolts. Or 10 power 3 of millivolts. 1 volt is 10 power 3 of millivolts. Inversely, 1 millivolt is 1 over 1,000 of volts. 1 millivolt is 1,000 times smaller than volt. 1 over 1,000 of volts. Or you can write this is a 10 power negative 3 of volts. Okay, so that the other unit of volt is a microvolt. So this is similar to current, microvolt. Right, microvolt or U volts. This is a microvolt. One volt is a 1 million microvolt. Micro is million. Is 1 volt is 1 million microvolt, or it is 10 power 6 of microvolts, 1 volt. And 1 microvolt is 1 over 1 billion of volts. Or you write this is a 10 power negative 6 of volts. Okay? Now, return to our Ohm's law. V is R times I. This is the basic Ohm's law. V is R times I. So R in ohms, I in ampere, and V in volts. Now, our previous example here, R in 100 ohms. Current I is 2 ampere. Yeah. When you take 100 ohms multiplied by 2 ampere, your 10 here is how much? 200 volts. So this is what we studied in the previous exercise, previous example. Now, other example. If R here, for example, if R is 500 ohms, current now is point. No. Now, 500 ohms. The current I is 4 milliamp. You take a 500 ohms times 4 milliamp. Now, what will be the voltage here? So, R in ohms, current in milliamp. So, milliamp is 1,000 times smaller. So, the voltage instead of volt here, we have millivolts. Ohms multiplied by milliamp, you have 10 millivolts. If R is 500 ohms, current is 4 milliamps, you multiply, you obtain 2,000 millivolts. 500 multiplied by 4, you obtain 2000. But the unit here, ohms multiplied by milliamp, you obtain millivolts. So 2000 millivolts, it means that this is 2 volts. Now, instead of writing R 500 ohms, we write in kilo ohms. 500 ohms is how many kilo ohms?
0.5.
0.5 kilo ohms. R is now 0.5 kilo ohms. Multiplied by the current 4 milliamps. So what will we have? Kilo ohms here is 1000 times larger. Milliamp here is 1000 times smaller. If you multiply them, they cancel each other. Is right? Kilo is 1000 times larger. This is 10 power 3. Milli, 1000 times smaller. This is 10 power negative 3. Then, if you multiply them, 10 power 3 and 10 power negative 3 will cancel each other. And finally, the value here, you obtain here, 0.5 multiplied by 4, you obtain 2. 0.5 multiplied by 4 is 2. And the unit 2 here is in volts. In volts, because kilo ohms cancel with milliampere. Okay, and then you obtain directly volts, 2 volts. Okay, so in brief, I like to repeat. If R in kilo ohms, current in milliamps, so they will be cancel each other, and then the voltage now will be in volts. If R in kilo ohms, current in milliamp, so the voltage will be in volts. So please remember this. Remember this for your calculation. Okay? Now, next. I add one more page. Now, return back to Ohm's law. V is R times I. So we have a resistor here, R, voltage is V and current is I. So we calculate the voltage V by taking resistance R multiplied by the current I. This is Ohm's law. Now, V is R times I. We can also rewrite this law in the other way. I is V divided by R. I is V divided by R. So this is the same formula, the same law, but now we write in a different form. I is V divided by R. If we know voltage V, if we know resistance R, you calculate the current. I is V over R. So this one is also Ohm's law, but written in the other way. We calculate the current I by taking voltage V divided by R. Is it right? If we know voltage, if we know resistance, you calculate the current. Okay? Or you can write R is V divided by I. If we know the voltage V, if we know the current I, you could calculate the resistance R. R is V over I. Okay. Okay. So in this formula, V is the unit volts, R unit ohms, and the current I the unit ampere. So these are the basic units. V in volts, R in ohms, current in ampere. Or in the second case, V in volts, current I in ampere, and then R now in ohms. Okay? Now, one question. I is a V over R. If V in volts, if R in kilo ohms, what is the unit of I here? In milliamp, yes, milliamp. I is V over R. If V measure in volts, R measure in kilo ohms, so the current I will be in milliamp. Do you understand? Mm-hmm. Now example. Now example. Voltage V is 10 volts. Okay. R is 4 kilo ohms. Then how much is the current? If you measure the voltage 10 volts, the resistance is 4 kilo ohms. So what is the current?
0.5 million.
The current will be I is V over R. V 10 ohms. V is 10 volts divided by R is 4 kilo ohms. Okay, so you should obtain 2.5, and the unit here it will be in milliamp. Do you understand? Now, similarly, for the second formula, R is V over I. Now, if V measured in volts, I measured in milliamp. So what is the unit of R? Kilo ohms. Kilo ohms. Now, example. If V is 10 ohms, so similar is the previous case. If V is 10 ohms, I is 2.5 milliamp. We are given voltage V 10 volts. We are given the current I 2.5 milliamp. So we calculate resistance R. R now is V over I, which is 10 volts over 2.5 milliamp. Yeah, so that you take 10 divided by 2.5, you receive 4. But the unit here, voltage in volts, current in milliamp, so resistance will be in kilo ohms, 4 kilo ohms. Okay, so I repeat, all three formula here, they are Ohm's law. So they are the same law, Ohm's law. But depending on what we are given, we calculate the others. Okay, we use a V is R times I, or I is V over R, or R is V over I. Okay, it depends on what we are given. Okay, but the whole method is Ohm's law. Ohm's law. Do you understand? Now, let's do some certain exercises. Okay. Now, let's do this practice exercise. Now, suppose we have a 4-band resistor, 100K plus or minus 10%. So which one is the correct color code? Yeah. Which answer?
4. Letter D.
D, yes. D. This is a D. D. Now, 100K. 100K, what does it mean? 100K, that means 100,000 of ohms. 100K. 100K. Which is 100,000 of ohms. So the first digit is 1. It 1. What is the color of 1? Brown. Brown. Okay, the first digit. The second digit is 0. So the code is the color is black. And this is a 4-band code. So we need the first digit, second digit, and the multiplier. So here we have multiplier here. We have 40. That means we have to add 4 number 0 after the first and second digit. So 4 is what is the color of core 4? Yellow. Okay, yellow. So finally, our code here will be brown, black, yellow. 10% here. This is the band number 4. This is a silver. This is 10%. So brown, black, yellow, silver. So the correct solution, the correct answer is B. Brown, black, yellow, silver. Okay. Any question? Now, next. This is a 4-band code. 4-band code. So this is a brown, black, brown, gold. So what is the value of this resistance?
100
Ohms.
5%.
Yeah. Brown here. Brown here, this is 1. Black, this is 0. And brown here, this is also 1. And gold here, this is a plus or minus 10%, 5%. So you write 1, 0, and add 1 more 0. Add 1, 0. So this is 100 ohms. So the value here it will be 100 ohms plus or minus 10%. Sorry, 5%. Plus or minus 5%. Okay. Now next, this one. Green, blue, yellow, green, silver. This is 5 band. 5 band. Yes, yes, but I need to convert into ohms or kilo ohms or mega ohms.
6.45 mega ohm.
Sorry,
6.45 mega ohm.
yeah, 56.4 mega ohms. You need to convert into the unit ohms or kilo ohms or mega ohms. So the first digit, green. Green. Green is which number? 5. 5. Next, blue. Blue is which number? 6. Yellow is number 4. And green is number 5. And silver here is plus or minus 10%. So the multiplier here, it will be 5. 5. So the first digit is 5, second digit is 6, the third digit is 4. And then we add 5 number 0. 1, 2, 3, 4, 5. So add 5 number 0 after that. So finally, we have 56,400,000 ohms. Okay? 56,400,000 ohms. So you need to convert into kilo ohms or mega ohms. So the best way is 56.4 mega ohms plus or minus 10%. Okay? Or if you like to write in kilo ohms, how many kilo ohms is this? Yes, 56,400 kilo ohms plus or minus 10%. Okay? Any question? Now, we practice on Ohm's law. We are given the current 0.01 ampere. Voltage 4 volts. Calculate resistance. So how much is R? 400 ohms. Okay, so R here, R is V over I. This is Ohm's law. R is V over I. V here is 4 volts. I is 0.01 ampere. If you divide, you obtain 400. And the unit here, voltage in volts, current in ampere, so R in ohms, 400 ohms. Okay? Now, question B. Current I, 50 milliamp, R, 560 ohms. Calculate the voltage. Sorry?
28 volts.
Yeah, 28 volts. So now, also Ohm's law. V is R times I. Okay? R here is 560 ohms. I here is 50 milliamp. So if you multiply, you should obtain 28,000. But what is the unit here? 28,000. R in ohms. Current I in milliamp. If you multiply them, you should obtain the unit here in millivolts. Millivolts. 28,000 millivolts. Okay? Or 28,000 millivolts. This is 28 volts. Okay? Now, the last question. V is 12 ohms. R is 1.5 kilo ohms. What is the current? Eight.
8 amps.
8.
8 amps.
No. 8.
Oh. 8 million.
Yeah, 8 milliamp. Now, Ohm's law. I is V over R. V now is 12 ohms. R here is 1.5 kilo ohms. Kilo ohms. Okay? So if you take a 12 divided by 1.5, you obtain 8. But the unit here, voltage in volts, resistance in kilo ohms. You divide, you obtain milliamp. Current will be 8 milliamp.
So if it's kilo, it steps down to milliamps?
Yes, voltage in volts divided by kilo ohms,
Yeah.
so obtain in milliamp.
Okay.
Okay. Okay, any question? Okay, so now these exercises I will post on Google Classwork. Okay, so that you can review after that. Okay, you can review and recalculate by yourselves. Okay, so we will stop here today. And I like to repeat that tomorrow, everyone please bring the trainer, multimeter, all the materials with you. Tomorrow we do the lab 0. And I will post the homework 0, the introductory homework this evening.
Due tomorrow.
Yes, due tomorrow. So please, everyone, so this homework 0 is very easy. You can answer, write out on the paper, take the picture, and post and submit on Google Classwork.
Okay.
So this is for practice, for
You just write
submission.
it down, take a picture. and send it.
Yeah,
Oh,
yeah. You should do that. It is better. Okay.
Thank you.
Okay. So goodbye, class. See you tomorrow.
Okay, sounds good. Thank you.